Volcanoes are sleeping giants. Woe betide us should they awake. Millions of people live in their shadows and very close to a looming catastrophe. But even giants, far away and long forgotten, can suddenly come alive. Looking at history, we come to understand that active volcanoes also need to be reckoned with in the future. Volcanologists, climate researchers, geologists, they all want to learn from previous catastrophes in order to save lives in the future.
In a way, they're like Beauty and the Beast.
Can we protect ourselves from this danger?
We can't always predict these events. People will die.
Istanbul is Europe's largest metropolis. More than 14 million people live here. But few of them know that the eruption of a volcano has shaped this city's destiny. History shows what's in store for many cities around the world, because no matter how far away the volcanoes are, no one's truly safe. In the year 541 AD, Istanbul is still called Constantinople. A foreign plague decimates the population of the Byzantine capital. Millions of people die. Emperor Justinian and the entire country are desperate. An invisible foe has taken over the empire.
Your Majesty, the air we breathe is so bad. A pestilence has spread to the city. What do you plan to do?
Those who are righteous have nothing to fear.
Then ask the heavens what we've done. The city is full of corpses. What is the true reason?
The answer to this riddle might be found 1.5 millennia later and more than 3,000 kilometers further north. A small international team of researchers has put up their tents in eastern Greenland. They are here to research the climate of the past. Johannes Freitag of the Alfred Wegener Institute hopes to retrieve information from the ice on how the climate has changed over the last millennia.
Good to see you.
He is in search of sudden climate changes. Greenland is an inhospitable place. Even in summer, the temperatures cool down to minus 18 degrees Celsius. But here, far from civilization, is the perfect place for ice core drilling. Because the ice here is very thin, 100,000 years of climate history are deep frozen and only half a kilometer depth. The exact location of the drilling site is key. If there are any anomalies in the upper layers, it needs to be relocated.
It goes down until this layer. Here you can see the melted layer. It's refrozen meltwater from last summer. And so below here, there's massive ice.
Und hier unten, also massives Eis.
The fine layers are like growth rings. It's important not to destroy them during the retrieval. An annual layer measures about ½ a centimeter. So the researchers are slowly stepping back in time. But the work has to be broken off every now and then. The drill can't heat up, or it would melt the ice. The layers have been reached from around the time of the plague. Does the ice give any indications about the trigger of the disease?
Go. 30. 50.
The electrical conductivity of the drilling core confirms the suspicion.
90.
In the 6th century AD, the ice suddenly points to a shift.
Come and have a look here.
There was a sudden increase in the atmosphere's sulfur content.
Small here, so yeah, exactly.
Very clear.
So that's rare.
This must be a volcanic peak. It is quite high and present in 10 centimeters of the ice. That equals about 2 years. We don't know the time period for sure right now because we don't have the exact determination of the age of the ice.
Volcanoes are fed by the hot inner core of the Earth. Driven by this heat, magma rises out of the Earth's mantle in slow currents and accumulates under its thin crust. The molten rock also transports a whole mix of poisonous gases to the top. Could the mysterious epidemic stand in close relation to the eruption of a volcano? Before the city was struck by the unknown disease, the sky darkened. There are precise accounts dating back to the year 536 AD.
For months, the sun has been weak, in summer as in winter. Everyone fears it might never come back. The wine is sour, and the harvest is lean. There is so much snow that the birds are dying.
It is as though hell had crept out of the depths of the earth. Historian Mischa Meyer of the University of Tübingen has analyzed the accounts to understand what exactly happened back then.
Im 6. Jahrhundert ist die Bevölkerung ohnehin sehr sensibel.
During the 6th century AD, the population is already very wary of anything it sees as abnormal. This is due to a fatalistic view of the world that was quite popular back then, and to a sort of waiting for the world to end attitude that fostered any thoughts of the coming doom. Any sign would do, and this unusual weather obviously fit in quite nicely.
Diese Wetteranomalie natürlich sehr gelegen.
Scholars had predicted the end of the world to occur at the beginning of the 6th century. And every change in the environment was seen as a sign of the coming Last Judgment. And indeed, change was coming, but much different than people back then expected. Are testimonies of an almost forgotten catastrophe. Its cause, a seemingly insolvable mystery. The Earth itself keeps destroying life on its own surface. Because volcanoes spew out not only ashes into the Earth's atmosphere, but sulfuric gases as well. During massive eruptions, they catapult sulfur as high as 1 kilometer into the air. Once there, the sulfur mixes with water, This creates a layer of clouds made up of sulfuric acid that barely lets in any sunlight. A more recent example shows the effects this can have. In 1815 in Indonesia, the Tambora volcano awakes. Its actual eruption only lasts for 3 hours. In this short time, ashes and ash flows kill about 10,000 inhabitants. But its cloud claims many more deaths around the world. By this time, the world had already grown so close that the word about the catastrophe has spread to Europe. Shortly afterwards, the sulfur reaches our continent. The clouds color the sky a deep red. There are breathtaking sunsets that have been captured by William Turner and are preserved until today. But this beauty is the harbinger of a catastrophe. What follows are cold spells, bad harvests, and the biggest famine of the 19th century. The number of victims of Tambora's sulfur clouds can only be estimated. On a global scale, the volcano probably cost 10 times the amount of lives than the eruption in Indonesia. In Germany, many people are forced to flee their home. The ice cores from Greenland are analyzed in the Alfred Wegener Institute in Bremerhaven. Will the suspicion of a volcanic eruption in the 6th century, the century of the mysterious disease, be confirmed? There are hundreds of samples stored in cold chambers. It is one of the largest ice core storages in the world. Until now, the volcano that poisoned the climate in the 6th century hasn't yet been found.
We want to reconstruct the climate on the entire planet to piece together the puzzle. That is why we have ice cores from all over the world.
The analysis of the core from Greenland confirms it. The traces of sulfur actually do stem from the 6th century. At the same time the cold spell reached Constantinople, a previously unknown volcano covers the northern hemisphere with a cloud of sulfur. But the scientists have a suspicion. Could it be that within a few years there wasn't just one, but in fact 2 eruptions? And indeed, the laboratory analyses show that a few centimeters further, there is another indication of sulfur. A second volcano had poisoned the climate just a few years after the first, and the epidemic follows this eruption. The eruption left traces on the North and the South Pole. The volcano that spit them out must therefore be found in the middle, close to the equator. In El Salvador, hidden away from the world until now, lies the Ilopango. The traces of its last eruption have long since been overgrown by the tropical rainforest. Robert Dole of the University of Austin, Texas, has specialized in the study of past ecosystems. He is convinced that the Ilopango is responsible for the climate chaos in the 6th century, and he is looking for evidence to prove his theory.
The volcano is basically the lake. What you see here is an outline of the entire area that was erupted all at once when this volcano erupted 1,500 years ago. So instead of just having a single vent where lava would come up through a single vent, we have many vents, and all of that material was expelled explosively at once.
The eruption must have been immense. It buried the entire area under a several-meter-high layer of ashes. Volcanic ash doesn't have a lot in common with regular ash. It is finely scattered rock. The force of the explosion ripped apart huge amounts of lava and turned it into dust.
We find an ash that's light in color like this. It's very exciting for someone like me because what it tells us is that it's both high in silica and that it was erupted explosively in a geologic instant. It might have been a day, might have been 2 days, but a huge amount of material was erupted all at once, which tells us of the strength and magnitude and sheer immensity.
Robert Dole tries to reconstruct exactly what happened during the eruption. He interprets the geological traces that are invisible to most people. As long as the giant is asleep, nothing tells of the danger lying beneath. Even back then, the volcano was a crater lake. Its magma chamber lies underneath. The pressure in it slowly increases until it reaches a critical point. The gases that are freed in the molten rock start to ascend. Steam, created by the heat of the magma chamber, settles over the landscape like fog. Until suddenly, the roof of the chamber flies up like the cork of a bottle of champagne. As the eruption column falls back into itself, pyroclastic streams flow over the Earth. The ash clouds, as hot as 700 degrees Celsius, destroy everything in their way.
Not only do they flow over the edge in huge sheets, but they flow through the valleys and up mountainsides. And there's some estimates that they flowed as high as 1,500 meters in some places, up hillsides, according to geologists working in this area. So you can't outrun these events. You cannot outrun a pyroclastic flow. You can't hide from a pyroclastic flow. You die in a pyroclastic flow.
It's unlikely that anyone in a radius of 1,000 square kilometers survived this inferno. Today, only the ashes show just how big the eruption was.
The size of the eruption, by measuring the thickness, not only right by the crater itself, but as we get further and further away, the more measurements we have, the more accurately we can estimate the size of the eruption itself.
In order to discover the world's biggest volcanoes, one can't solely rely on the search on land. The ship Meteor carries a team from the Kiel Research Institute Geomar that will examine the ocean floor around Cape Verde. There is a steel pipe on the underside of the 2-ton weight, which is supposed to be jammed into the seabed. That way, it is possible to extract a drilling core of about 9 meters, but only if it doesn't hit a spot on the ground that is too hard. The gravity core has to sink down to about 3.5 kilometers until it reaches the seabed. At a speed of 1 meter per second, this can take up to an hour. Time and again, sediment coring continues to unveil previously unknown volcanic eruptions. Important information in order to understand the impact of volcanoes on the history of the Earth. The actual success of the team was uncertain, but at 8 in the morning, hope turns to certainty. The drilling has succeeded. The drill sleeve contains everything that has swept over the ocean floor for centuries, even volcanic ash. Volcanologist Stefan Kuterov collects samples of this ash from all over the world. He is eager to discover the frequency of big volcanic eruptions.
Once we find 10 layers of ash in a core, we examine in what direction the ashes flew. Only with the information of dissemination at hand is one able to make other predictions, like the volume that came out of this eruption.
The sediment cores have a big advantage. Other than sulfur, ash can be traced back to a particular volcano. It is like a fingerprint. Every volcano and every eruption is unique. In the Geomar Institute in Kiel, there are samples from all around the world. The ashes of the ocean floor can therefore be traced back exactly to a particular eruption. Stefan Kulterov has brought in several sediment samples of the Pacific Ocean floor, close to Central America's coast. The type of crystals in the ashes alone can reveal their possible origin. The volcanologist has a suspicion. The mineral is typical for the last big eruption of the Ilopango volcano. The exact composition reveals that the ashes are indeed from El Salvador, even though he has found them hundreds of kilometers further away on the Pacific Ocean floor.
By doing so, we could place the marine ash layers that we found and that had previously been undiscovered in correlation with the eruption of the Ilopango. Now we have a result of an expansion of 1.2 million square kilometers, which is about 4 times the size of Germany.
This proves that the eruption of the Ilopango catapulted more ash and gas into the atmosphere than any other volcano has in the last 2,000 years. Today, buildings cover the ash in many places. As a matter of fact, the capital of San Salvador was built on it, 16 kilometers away from the still active volcano. No one is prepared for a possible eruption of the volcano, especially not on the scale that the amount of ash of previous eruptions suggests. The country has other, more pressing problems. There are, however, 6 million people living in a radius of 100 kilometers around the volcano.
Anywhere between North America, Central America, and South America, no country is more densely populated than El Salvador. What does that mean? There's land scarcity. There's not enough room for all these people to live. So to think of moving an entire city like San Salvador, or even to ask people to move off the flanks of a volcano that we know is active, is very, very difficult, because that's all they have.
Therefore, it is even more important to examine the early eruptions of the Ilopango. Robert Dole wants to get an impression of the area around the crater lake. He hopes to find regional indications of the last big eruption of the volcano, because the dispersion of the ashes reveal which areas might be in danger in the future. Generations have settled in this area without even knowing about the volcano's existence. The giant has been dormant for several centuries, and no one remembers the big eruption. Was it really a trace of sulfur from here that was found in the ice cores?
If you look across this valley now, you can see it's a broad, relatively flat valley that's quite rich with all the volcanic material that's fallen over thousands of years and developed into rich agricultural soils. So you can see why people were attracted to this region in the first place.
Agriculture has erased the traces of the eruption even further. This makes it almost impossible to determine the exact time of the eruption. Volcanic ash is made up of inorganic material, like stone or fragments of glass. Their age is indeterminable. Robert Dole has to rely on the remains of living beings that died during the eruption. Wood is a great help here. It was carbonized in the scorching ash, but didn't burn up completely due to the lack of oxygen. That is how it is possible to narrow down the exact time of the eruption.
It's a time capsule. It's a precise moment in time that's captured in this ash. So when we dig these pieces of wood out, the smallest pieces that we find, the big tree trunks that we find, any piece of wood that we're able to pull out of this ash can then directly be associated with the time of the eruption.
Por eso se quemó. Por esas cenizas venían calientes.
These are rare moments of joy for Robert Dole and his colleagues because the carbonized wood has chemical substances that steadily decompose over the years. The tree's time of death can be determined by measuring the decomposition in the laboratory.
Tenemos su misma forma de antes, y si podemos ver.
These samples have helped us narrow the dating range from 120 years down to more like 20 years. And we've really been able to pinpoint and say, yes, Ilopango was not a 5th century eruption. It happened in the early 6th century AD.
Following the eruption, there was a cold spell of 15 years that reached all the way to Constantinople. Once there, the unknown disease spreads further. In desperation, people turn to religion. Emperor Justinian even mandates forced baptisms to appease the alleged wrath of God, but to no avail. More and more residents fall sick and die. The disease spreads from Asia all the way through the East Roman Empire and to Europe. Its trace goes all the way to Munich. In the suburb of Aschheim, so many people died within a short time period that several bodies had to be put into the same grave. But here, time has erased almost all traces. The only surviving evidence could possibly be found in the people's teeth. Holger Scholz of the Institute for Microbiology of the German Armed Forces hopes to solve the riddle by using forensic methods. Special suits protect the samples against contamination because one skin flake alone is all it takes to soil the last DNA samples before their analysis. The scientists managed to isolate the genetic substance. It belongs to a bacteria that caused the deadliest infectious disease in the history of humankind, Yersinia pestis, or the plague.
The cooling off that happened back then led to further weakening of the population. There were extreme famines, and that meant that people didn't have enough to eat. Even rodents, that are an important factor for the transmission of the plague, retreated to the cities, where there was still some food left, and that is obviously how humans came into more contact with the pathogens.
The plague's bacterium actually feeds off the blood of rodents. The connection to humans is created by fleas. Once the flea changes its host, it transmits the pathogen, and the risk of an infection increases with every animal a human has contact with.
There was terrible hygiene. The immune system was severely weakened, and all that furthered the expansion of the pathogen, which in turn cost the lives of millions of people.
Far away, the Ilopango in El Salvador changes the climate. Famine ensues. The population becomes more vulnerable to the plague. The disease can strike anyone. It blurs the lines between the rich and the poor. Panic and chaos ensues. There is no more food. The emperor cannot uphold law and order.
The fact that the emperor himself was struck with the plague obviously increased the insecurity immensely. And if one is seeing this as one of God's plans, it was clear that the emperor is being punished and therefore was losing the grounds of his legitimate rule.
Even the emperor, who was godlike in the eyes of the population, is struck by the plague. In view of the span of a human life, volcanic eruptions that trigger climate chaos are comparatively rare. So rare, in fact, that their risk is often forgotten. But they have, nevertheless, been present throughout history. In 2014, danger came very close. The Barabunga volcano in Iceland had been belching out lava for several months, and it still pumps about 35,000 tons of sulfur dioxide into the air. No one knows yet how the eruption will develop and when it is going to come to a halt. The volcano is located under Europe's largest glacier. Once the lava comes too close to the ice, there's a possibility of a hydrogen explosion. If this were to happen, the gases would rise up even higher. And Iceland is close to Western Europe. The sulfur could make it all the way to Germany, even without such an explosion. One look into history reveals the possible consequences. The winter of 1784 was one of the hardest ever to hit Central Europe. And the following spring, meltwater and ice flooded down the rivers. The flood breaks bridges, causing many stretches of land to disappear. There are severe floods in Würzburg and other cities. Cologne reports a water level of almost 14 meters, the highest water level ever measured. Even at the start of the eruption, volcanic gases drift to Western Europe. John Grattan, a geographer at the University of Wales, has assembled accounts of contemporary witnesses.
On the 23rd of June 1783, people across Western Europe woke up to a changed world. Forests being stripped of their leaves, and there's an intense smell of sulfur in the air.
The cause of the disaster was the Icelandic volcano Laki, a giant gap in the earth that produces more than 6,000 cubic meters of lava per second. Within 8 months, it releases approximately 120 million tons of sulfur dioxide, which travels to Western Europe and changes the local climate.
There are very clear descriptions of people struggling to breathe, of an uncomfortable pressure, palpitations of the heart, of mysterious agues and fevers, of outbreaks of terrible diarrhea, the bloody flux.
There are theories that imply that the Laki eruption is co-responsible for the French Revolution. Ever since then, Laki has been dormant. But what would happen if the giant awakens again? Today, the atmosphere is a lot more polluted than during the eruption of Laki. Calculations show that today 430,000 people died prematurely due to the effects of dust particles. Industrial plants and traffic pollute the environment, not only through emissions of carbon dioxide, but also through very small particles in the air. Volcanic gases would burden the atmosphere even further. Scientists have calculated that if this were to happen, there would be 140,000 more deaths per year. The purpose of the Federal Office of Citizen Protection and Disaster Assistance in Bonn is to organize quick aid in times of crisis. Christoph Unger is in charge of the institution. He and his co-workers develop strategies to prepare for multiple instances of crisis. Are we prepared for a volcanic eruption happening far away?
At the moment, we are not preparing for gases or dust particles in the air that might reach Germany.
But the consequences of a volcanic winter are comparable to today's weather extremes. The onset of a cold spell could have far-reaching effects, as the example of the Münsterland shows. In 2005, there was a snowstorm leaving up to half a meter of snow. Power poles fall over under the weight, and there are entire stretches of land that are plunged into darkness. 250,000 people are without electricity, some even for several days, and that was relatively harmless. A blackout of a larger area would be disastrous.
No radio, no TV, no computers. There's hardly any cash left, so you can't buy anything. Gas stations need electricity to pump gasoline. Security systems wouldn't work. It would have a huge impact on our social life.
In the last years, Germany has repeatedly had to fight with cold weather and high water levels, but not to the extent as after the Laki eruption in the 17th century. In such a catastrophic case, the danger of infectious diseases would increase. What would happen if 30% of the population fell sick?
We have a problem of supply, because the supply chains would break. There'd be very different kinds of problems in security, in vulnerable institutions, where there wouldn't be enough personnel at hand. And there's even the question of who would be vaccinated and when. Who will receive the very short supplies of vaccines? This would lead to an immense impact on all areas in society as a whole.
The residents of Constantinople don't fare any different, and not knowing the cause of the disease makes them even more afraid. More and more, the city is overwhelmed with the plague. It isn't just the people that fall sick, but the system itself that is beginning to fail. Panic ensues. Civilization unravels.
Es war einfach nicht mehr
There simply wasn't enough population and military capacity to protect these regions and these cities, because the plague had decimated too many of them.
And it isn't just the effects on the people's health. The plague kills soldiers and taxpayers. Trust in the power of the state has been gravely damaged. Even after 100 years, the empire cannot defeat the onslaught of the Arabs. And that is how the eruption of the Ilopango might have also heralded the end of antiquity itself. Since the time of Emperor Justinian, the world population has grown to over 7 billion people. And more than half of them live in cities and depend on transport, trade, and telecommunication. Can you protect all these people against a volcanic eruption with a global effect? There are about 1,500 active volcanoes worldwide, but only 100 of them are under local surveillance by observatories. And the last eruption of the other volcanoes isn't even known. But even if the volcanoes are well monitored, an eruption is still hard to predict. Even experienced scientists can make horrendous mistakes. In 1993, an international team of researchers performed measurements on the peak of the Colombian volcano Galeras. They are in good spirits. Nobody seems to be bothered by the mist that covers the view on the crater. Suddenly, the volcanologists are taken aback by a hydrogen explosion. Rocks and small particles fly up in the air. One part of the group is still on the inside of the crater. There is no hope for these 9 people. Others are severely injured. A joyous trip has turned into a nightmare. Only 2 months later, the volcano erupts again. This time, it also hits the scientists' research station that was seen as secure at the time of the first eruption.
So even in modern times, even in the developed world and rich countries, the level of preparedness is not adequate to handle such a large, sudden event. And no matter how many instruments we have measuring small earthquakes and measuring the Earth's elevation as it rises in anticipation of an earthquake, we can't always predict these events.
So even if scientists know that a volcanic eruption is about to happen, do they know the course of the eruption? In 1980, Mount St. Helens announced another eruption through several small earthquakes. It is located on the west coast of the USA, close to the major cities of Portland and Seattle. Richard Waite of the U.S. Geological Survey witnessed the eruption. As so many others, he was convinced that he knew what was going to happen.
By late March, this word bulge was on everybody's lips. So that it got big enough that, and the volcano's steep enough that many people suspected it's at some point it's gonna start landsliding. What was expected is that there'd be a series of small landslides, and that would be a warning and people could get out.
The eruption was announced in the media and drew more and more onlookers to the area. But then Mount St. Helens erupts in a totally unexpected way. An earthquake lets the entire north slope slide down. The mountain explodes due to the loss of pressure. Mud and small stones rush down the hillside.
No, that was not anticipated. It went over one ridge, down into a valley, over the next ridge, and just kept going out and out. 20 kilometers, 30 kilometers maybe, I don't even know how far it went, but way out. And nobody anticipated anything like that.
Ash clouds and mudslides overrun the fleeing people. 57 people die. Among them are scientists that miscalculated the impact of the eruption. The surrounding area is covered in dust. 540 million tons of volcanic ash are dispersed over an area larger than the Netherlands. Only weeks later, the immensity becomes clear. There is a huge hole in the volcanic cone. The desertificated area in front of the opening is over 600 square kilometers large. As a comparison, the eruption of the Ilopango in 540 AD was about 10 times as large.
So we do know that modern science can help us predict somewhat when these events will occur. But we've never been tested on the level of Ilopango. We've never had a massive eruption of this size near a densely populated urban center. Never. So what happens when this happens near Seattle? What happens when this happens in Naples? Will our technology be good enough to get everybody out?
There are more than 67 large cities worldwide located close to an active volcano. That means there are about 116 million people living dangerously close to these giants. There are already 37 million of them living in the area of Tokyo, in the shadow of Mount Fuji. Its last big eruption happened more than 300 years ago. Geologically speaking, this is the blink of an eye. If it were to erupt, its ashes would destroy the entire infrastructure of the city. The situation in Seattle isn't much better. Scientists see Mount Rainier as one of the sleeping giants that could erupt at any time. Even in Europe, it's dangerous. Mount Vesuvius alone could destroy Naples entirely. But there's an even larger magma chamber in the Bay of Naples. The Soufriere Hills volcano, located close to Plymouth, the capital of the Caribbean island of Montserrat, can provide a glimpse into the possible effects of an eruption happening close to a city. Before the city was buried under its ashes several times, there were 4,000 people living here. Hardly anyone has stayed. Today, Plymouth is a ghost town. Volcanic eruptions are a global threat, but their awakening also offers new possibilities, because with every one of these eruptions, scientists learn more about them. One such example is Mount St. Helens. Even if every giant is unique, a few of the results taken from here can be applied to other volcanoes as well.
Okay.
It is a birthplace to modern volcanology in many ways. Especially some of the extraordinary events. This landslide, I mean, there's probably 400 or 500 volcanoes around the world now that have had a landslide, and we know it because of this. I mean, this is what opened the door to understanding that.
Only a few years ago, a young geologist developed a groundbreaking method. It enables us to predict a volcanic eruption more precisely. Today, experts from the U.S. Geological Survey fly to the top of the mountain several times. Down here, it's about 30 degrees in the shade. But on top, the scientists have to deal with very cold temperatures. Angela Diefenbach monitors the volcano from the air. The most important point for her is that the method is simple, flexible, and affordable enough for developing countries, where a lot of volcanoes are not monitored on a regular basis.
You can use a point-and-shoot camera or a smartphone camera. You just want to make sure you have good lens characteristics. So you don't want, like a GoPro camera wouldn't be that good for this type of work because you have a lot of radial distortion, and that translates into your model.
Currently, there is a plug of cold lava that keeps the volcano shut. This so-called lava dome is dangerous because it stores pressure underneath it. Any change in the surface could be a sign of a possible eruption. Angela Diefenbach shoots her photos from a precisely chosen angle. The brilliance of the idea is that the photos form a basis on which her computer generates an exact 3D replica of the volcano. If she then compares the data to earlier flights, the smallest changes become visible immediately. This method can even be applied during an eruption, because it is often in the last moment that one can predict how the giant is truly going to act.
Well, this particular lava dome doesn't pose much of a threat because it erupted very slowly and it was relatively cool when it erupted. But other lava domes at other volcanoes tend to collapse, either from big explosions or by gravitational forces. And when they collapse, they produce pyroclastic flows, which are very dangerous to people.
Mount St. Helens is a very well-monitored volcano, but there are many sleeping giants all over the world that can hardly be researched. There is a huge seething lava lake in the Democratic Republic of Congo, for example. The Nyiragongo lies in the middle of an area that is torn apart by civil war. And even if the giants lie in sparsely populated regions, like the Tavurvur in Papua New Guinea, their load of sulfur can reach any corner of the world. This is why Angela Diefenbach's method is so beneficial. It helps to assess the risks. But scientists can nevertheless only warn in time. They cannot stop an eruption from happening. In the midst of big cities, life seems to be as safe as ever. But history shows that some things aren't as they seem.